There is something strange about Tower Bridge. You have probably seen it hundreds of times. Two enormous towers standing above the River Thames, Gothic arches, stone walls, a silhouette that looks like it has been standing in London for centuries. But almost everything you see is a disguise. Behind those medieval-looking walls are 11 tons of riveted steel. The stone is not holding the bridge together. It is hiding what is actually holding it together, and that is only the beginning. Because to build Tower Bridge, engineers had to sink enormous iron chambers into the bottom of the Thames and send hundreds of men inside them to dig through the riverbed, while ships continued sailing above their heads. And the man who designed the bridge never lived to see a single tower standing. He died just over a year after construction began. But there is something even stranger. Hidden beneath one of London's most photographed landmarks is a room that once had a very unusual purpose. It was used to store the bodies of people recovered from the Thames. So how exactly did they build a bridge that had to do two completely opposite things? It had to create a permanent road across the river, while at the same time allowing some of the tallest ships in the British Empire to pass directly through it, and somehow they pulled it off. This is the story of how Tower Bridge was built, and why the bridge you see today is very different from the one its designers originally imagined. London, late 19th century. The city is exploding. It is becoming one of the largest and most important cities on Earth, and the area around the Thames is the beating heart of the British Empire. But there is a problem. People living and working east of central London need to cross the river. The existing bridges are overloaded, and reaching them can mean making a huge detour. So the obvious solution is simple: build another bridge. Except there is one enormous problem. Just upstream from the proposed location are the docks, and these are not ordinary docks. They are some of the busiest commercial docks in the world. Huge sailing ships carrying cargo from across the British Empire are constantly moving through the Thames. And many of those ships have enormous masts. They cannot simply lower them every time they reach a bridge, so engineers are faced with a problem that sounds almost impossible. London needs a permanent road across the river, but the river must remain permanently to tall ships. Both things have to happen in exactly the same place. A conventional bridge will not work. A fixed bridge would block the ships. A bridge that completely would interrupt road traffic, so the solution has to somehow do both. A bridge that can move. A competition was organized to find a solution. More than 50 proposals were submitted, and some of them were spectacularly strange. There were ideas involving moving platforms, huge ramps, rotating structures, even designs that would have forced vehicles to climb enormous spirals just to cross the river. But none of them solved the problem elegantly enough. Then came a proposal from an architect named Horace Jones. Jones was already an important figure in London. He had designed several of the city's major markets, including Smithfield, Billingsgate, and Leadenhall. But despite his experience, he was not universally respected by his fellow architects. Some considered his work too practical, too municipal, not artistic enough. And that criticism would follow him throughout his career. Yet this supposedly unremarkable architect was about to design one of the most recognizable structures in the world. His basic idea was surprisingly simple. Split the bridge in the middle, then make the two halves rise into the air like the drawbridge of a medieval castle. Except instead of lifting a few tons, he wanted to lift enormous sections of a modern steel bridge. At the time, nobody had attempted anything quite like it on this scale. For the mechanical engineering, Jones worked with civil engineer John Wolfe Barry. And immediately, another argument began. Not about engineering, about appearance. Because the bridge was going to be built next to the Tower of London, a structure that had stood there for centuries. The idea of placing a giant exposed steel machine beside it was not popular. Steel was associated with factories, railways, industrial buildings. It looked modern. And modern was exactly what people did not want next to the Tower of London. So Jones came up with an ingenious solution. Do not hide the engineering. build the bridge from steel, and then hide the steel. The structural skeleton would be steel. Then the entire exterior would be covered with stone, granite, Portland stone, Gothic arches, decorative towers, turrets, everything necessary to make a 19th century machine look like a medieval castle, and it worked. From the street, Tower Bridge looked ancient. From inside, it was anything but. It was a gigantic piece of Victorian engineering wearing a costume. Parliament approved the project in 1885. Construction began in April 1886. And just a few months later, Jones received another piece of recognition. He was knighted. After a career in which some of his peers had questioned his artistic credentials, he finally had the project that would define his legacy, but he would not live long enough to see it. On May 21, 1887, Horace Jones died at his home in London. He had just turned 68. Construction had barely begun. There were no towers, no finished steel structure, nothing that looked remotely like the bridge we know today. Jones had designed the idea, but he would never see it standing. His project passed into other hands, and there is a remarkable detail here. The two men who ultimately completed the bridge were connected to two of Britain's most famous engineers. John Wolfe Barry was the son of Charles Barry, the architect behind the Houses of Parliament, and working alongside him was Henry Mark Brunel, son of Isambard Kingdom Brunel, one of Britain's legendary engineers. Barry also modified Jones's original design. The general concept remained, but the final structure was significantly different from the original plans. So the Tower Bridge we know today is really the result of several generations of engineering ideas coming together. And now, the hardest part could begin. Because before they could build the towers, they had to build the ground beneath them. Tower Bridge has two massive towers, but those towers do not simply sit on the riverbank. Their foundations had to be placed in the river itself. And that created another enormous problem. The bottom of the Thames is not solid rock, it is mud, gravel, clay, waterlogged sediment. And if you put a gigantic tower on top of that, it sinks. So the engineers needed to reach a much stronger layer beneath the riverbed. But they could not simply drain the river. The Thames was one of the busiest waterways in the world. Ships had to keep moving. Cargo had to keep moving. The river could not simply be closed for years while someone excavated the foundations. So the engineers used something extraordinary: compressed air. They built enormous iron chambers known as caissons. Think of them as giant metal rooms turned upside down. The bottom was sealed. The top was sealed. The chamber was pushed down into the riverbed. Then compressed air was pumped inside. The pressure pushed the water out, and suddenly workers could stand inside the bottom of the Thames without being underwater. But there was a catch. The men working inside these chambers were breathing air at much higher pressure than normal, and they had to excavate the riverbed by hand. They dug through gravel and clay, bucket after bucket. The chamber became heavier, and as material was removed, the entire structure slowly sank deeper into the ground. The deeper it went, the more difficult the work became, and the workers were facing another invisible danger: decompression sickness. When people leave a high-pressure environment too quickly, gases dissolved in the blood can form bubbles. The result can be extreme pain, joint damage, paralysis, and, in severe cases, death. At the time, the science was still poorly understood. Workers would emerge from the caissons suffering terrible pain, and nobody fully understood why. These men were literally building the foundations of one of London's greatest landmarks while risking their lives underneath the river. And above them, the Thames kept moving. Ships continued passing overhead. The empire's trade continued. London didn't stop. Eventually, the foundations reached the stronger clay beneath the riverbed. The chambers were filled with concrete. Around 70 tons of concrete went into the foundations. Then came another staggering figure. More than 30 million bricks were used in the construction of the bridge. And only after all of this could the visible structure begin to rise. The steel skeleton arrived, and surprisingly, the steel wasn't even manufactured in London. It came from Scotland. Around 11 tons of steel were assembled and connected with thousands upon thousands of rivets. Piece by piece, section by section, the two towers began to rise above the Thames. But the engineers were still hiding something, because all of that steel was going to disappear. Once the structural skeleton was complete, workers began covering it with stone. The industrial machine was becoming a Gothic monument, and slowly the Tower Bridge we recognize today began to emerge. But now we arrive at the part that makes Tower Bridge truly special. The bridge had to move, and the two enormous sections in the middle are called bascule leaves. Each one weighs more than 1 ton. Think about that. Imagine trying to lift a 1,000-ton piece of steel into the air in the 19th century. There were no modern electric motors, no computer-controlled hydraulic systems, no sophisticated electronics. So how did they do it? The answer is beautifully simple. They did not actually lift the entire weight. They balanced it. Each bascule has a huge counterweight hidden within the structure. The weight is positioned so that the moving section is almost perfectly balanced around its pivot. It behaves like a gigantic seesaw. If you have two children of almost identical weight sitting on opposite ends of a seesaw, you do not need to lift either child. You only need to give the system a push. Tower Bridge works on essentially the same principle. The engineers reduced the amount of force required to move those enormous structures, but they still needed something powerful enough to provide that initial push. And that something was steam. Inside the bridge were enormous steam-powered systems. Boilers heated water, steam-powered pumps. And those pumps forced water into massive hydraulic accumulators. These accumulators were essentially enormous pistons with huge weights sitting on top of them. The pumps slowly pushed the pistons upward. They were storing energy, not in batteries, not in fuel tanks, but in water and gravity. When a ship approached and the bridge needed to open, the stored pressure was released. The weighted pistons pushed down. The water was forced through the hydraulic system, and the enormous bascules began to rise. The bridge could open surprisingly quickly. And that is one of the things I find most impressive about Tower Bridge. It was not simply a bridge. It was a machine disguised as architecture. The stone was the exterior, the steel was the skeleton, and underneath it all was a hydraulic power plant. The engineers had another problem. Every time the bridge opened, pedestrians would have to wait. So they came up with an obvious solution. Build 2 elevated walkways connecting the towers. If the road was blocked, people could simply walk across the river above it. The walkways were more than 40 meters above the water. Inside the towers were staircases. In theory, it was perfect. In practice, Londoners hated it. Why climb hundreds of steps when you could simply wait a few minutes for the bridge to close? So most people did not use them. And empty elevated walkways created another problem. They became perfect places for criminals, pickpockets, and prostitutes. Eventually, the walkways became so problematic that they were closed in 1910. For more than 70 years, they remained largely empty. Then, in the 1980s, they were reopened, this time as a tourist attraction. On June 30th, 1894, Tower Bridge officially opened. The Prince of Wales was there. The Thames was packed with boats. And after 8 years of construction, London's newest bridge finally began doing the job it had been designed to do. But not everyone was impressed. Critics hated it. Some called it absurd. Others called it pretentious. Architects complained that the structure was pretending to be something it wasn't. A modern steel machine, dressed up like a medieval castle. Ironically, that criticism is exactly what makes the bridge so fascinating today. Because the thing they hated about it is now the thing that makes it iconic, and even the colors aren't what they originally were. For most of its early history, Tower Bridge was a much more subdued brown, The famous blue, white, and red color scheme came much later. It was introduced in 1977 for the Silver Jubilee, so even the image we associate with Tower Bridge is relatively modern. During its first year, the bridge opened thousands of times, around 6 openings. That works out to roughly 17 times every day. Imagine standing on the road in Victorian London and watching the entire bridge begin to rise. The traffic stops, the machinery starts. The 2 enormous sections move upward. A ship passes through, and then the bridge comes back down. But 2 incidents from Tower Bridge's history sound almost too ridiculous to be true. The first happened in 1952. A double-decker bus was crossing the bridge when the bascules began rising unexpectedly. The road beneath the bus started tilting upward. A gap was opening ahead. The driver had seconds to react. He didn't brake, he accelerated. The bus jumped from the rising section to the other side. It landed safely. There were minor injuries, but nobody died. The driver, Albert Gunter, was reportedly rewarded with £10 for his quick thinking. And then there was another incident. This one was even crazier. A Royal Air Force pilot named Alan Pollock was frustrated by the government's decision not to properly commemorate the anniversary of the Royal Air Force, so he decided to make his own statement. He flew a military jet over London, and when he reached Tower Bridge, he flew underneath it. A military jet between the bridge and the Thames. He was arrested after landing, and the incident was kept relatively quiet. But the image of a fighter jet flying beneath Tower Bridge remains one of the strangest episodes in the bridge's history. Tower Bridge also survived something much more serious: World War II. The docks surrounding the Thames were critical to Britain's war effort. That made them major targets for German bombing. Warehouses burned. Large parts of the port were destroyed, but Tower Bridge remained. It continued standing above the river. The bridge that had been designed to serve an empire was now helping the city survive a war. And yet, the biggest threat to the bridge's original purpose wasn't a bomb. It was a box. The container changed everything. Modern shipping containers allowed cargo to be moved faster and more efficiently, but there was a problem. Modern container ships became too large to travel far enough upstream. The port moved downstream. The docks around Tower Bridge gradually closed. And eventually, the very reason the bridge had been designed disappeared. The bridge had been created so enormous ships could reach London's docks. Now those ships couldn't reach the docks anymore. Tower Bridge had solved a problem that technology eventually made obsolete. In 1976, the original steam-powered system was retired. Electricity and modern hydraulics took over. But the original machinery wasn't simply thrown away. The old boilers, the engines, the hydraulic accumulators, they remained inside the bridge, preserved beneath the monument. Today, visitors can still see parts of that original machinery. A 19th century power plant hidden inside one of the world's most famous bridges. And here's one final detail about how Tower Bridge operates today. The river still has priority. If a vessel needs the bridge to open, it can request it in advance. Traffic stops, the bascules rise, and the boat passes underneath. The cars wait, the buses wait, the pedestrians wait. Because the bridge was designed around the river, and more than a century later, that principle remains. So let's put everything together. Tower Bridge was built because London needed a road without killing the busiest port in the British Empire. Its foundations were created inside enormous iron chambers beneath the Thames. Workers dug through the riverbed by hand while breathing compressed air. Around 70 tons of concrete went into the foundations. More than 30 million bricks helped create the structure. 11 tons of steel formed the skeleton. And all of it was covered with stone so the industrial machine would look like a medieval castle. Two bascules weighing more than 1 ton each can rise because they are balanced like enormous seesaws. The original machinery stored energy using water and gravity. The elevated walkways became associated with criminals and prostitution before being closed. The bridge survived war. A double-decker bus once jumped across its rising roadway. A military jet flew underneath it, and the original steam machinery is still preserved inside the bridge. But there is one final story, and this one has nothing to do with engineering. Horace Jones was told by his own professional colleagues that his work lacked enough artistic merit. He designed some of London's great markets. He was criticized. He kept working. Then he was given the project that would define his legacy, Tower Bridge. He was knighted while construction was underway, and just over a year later, he died. He never saw either tower standing. He never saw the steel skeleton. He never saw the stone cladding. He never saw the bridge for the first time. He never saw the thing that would make his name immortal. And today, millions of people know Tower Bridge. Almost nobody knows Horace Jones. He is buried beneath a modest grave in South London. Nothing like the enormous, elaborate structures he designed during his lifetime. But his creation became one of the defining images of London. And perhaps that is the strangest part of the entire story. The man accused of not having enough artistic talent ended up creating something that became a symbol of the city itself. But there is one more place beneath Tower Bridge that most tourists never see. A small room, white tiles, an iron door, hidden below street level. It became known as the Dead Man's Hole. Its purpose was remarkably simple. The Thames has powerful currents. People fall into rivers. Accidents happen. People drown. And the current can carry bodies towards certain parts of the river. Tower Bridge was one of them. So rather than leaving recovered bodies exposed on the riverbank, a room was created inside the base of the bridge. A place where bodies could be temporarily stored before they were taken away. Think about that. Every day, thousands of tourists walk across Tower Bridge. They photograph the towers. They look at the river. They admire the architecture. And beneath their feet, there was once a room designed for the dead. A hidden piece of infrastructure inside one of the world's most beautiful monuments. And suddenly, Tower Bridge looks very different, because the bridge isn't just what you see. It's everything underneath it. The foundations, the machinery, the tunnels, the chambers, the rooms, the forgotten spaces. And that raises an even bigger question. If one bridge can hide this much beneath the surface, what else is hidden underneath London itself? Because dozens of meters below the streets are sealed stations, wartime tunnels, abandoned passages, and forgotten structures that most people walk directly over without ever knowing they exist. And that's where the story continues. Tower Bridge was never supposed to exist the way we know it today. It had to be a road and a machine. A bridge and a drawbridge. Modern engineering disguised as medieval architecture. It had to stand on the bottom of the Thames without stopping the river. It had to lift more than 1,000 tons using technology from the 19th century. And it had to survive long enough to watch the world around it completely change. The ships became too big. The docks disappeared. Steam became electricity. And yet, the bridge remained. Still standing, still opening, still hiding its machinery beneath the stone. And perhaps that's what makes Tower Bridge so fascinating. Because the most impressive part isn't what London built above the river, it's what they had to build underneath it. Now tell us in the comments, what surprised you the most about Tower Bridge? The hydraulic system, the foundations beneath the Thames, the bus that jumped the bridge, or the hidden room beneath it? If you enjoyed this journey inside one of London's most iconic structures, leave a like, subscribe to Source Code, and turn on notifications for the next episode. Because the most incredible parts of the world's greatest landmarks are often the parts nobody can see. See you in the next one.